On number 1, it says, use the substitution method to find all solutions of the system of equations. So with systems of equations, we have many different methods. They, on this one, specifically want us to use the substitution method. And the first step of the substitution method is to isolate one of our variables. And we have really 4 choices here. We have the blue x, we have the blue y, we have the green x, and we have the green y. So I have to choose one of those 4 to isolate or get by itself. So the easiest one is actually the blue x, because all we need to do is just move the y over to the other side. So I have x is equal to y plus 1. So once you isolate one of your variables, you want to take that and plug it in for that variable, but in the other equation. So I've isolated for x in the top equation, and I want to plug that into x in the bottom equation. So I'm going to start with my equation. I'm going to leave a open parentheses. I'm going to put the rest of the equation. And then I'm plugging in one equation into another. Now, one of the checks at this point is that you should not see, or you should only have one letter. So there's going to be different colors here, but they should either be all y's or all x's. Again, there's different ways to solve this depending on which variable you're isolating for. So if I simplify this, this is 4y plus 4 plus 3y is equal to 18. And then if I combine, it's 7y plus 4 is equal to 18. And if I subtract 4 from both sides, 7y is equal to 14. And y is equal to 2. So I have most of my answer. I still need to get the x coordinate. In order to do that, I need to plug 2 into one of the original equations. So either plug it into here, plug it into here, or you can actually plug it into here. And that's the route I'm going to take because I'm trying to isolate for x, and x is already by itself, so that's actually the easiest one to do. But you could plug it into any one of the original equations. So x is equal to y plus 1, but I know what y is, it's 2. So 2 plus 1, or x is equal to 3. So my last step is to express this as an ordered pair, 0.32. And what this represents is the x and y value that work in both equations, both of my original equations. And graphically it represents the intersection point of the 2 lines. So each of these 2 equations represents a line, and the 0.32 is the intersection point of those 2 lines.